Welcome to the session on measures of central tendency and spread, variance and standard deviation. The objectives for this session are to calculate variance and standard deviation. We're going to begin by exploring why the mean is not enough to summarize a data set. Let's take a look at an example. The following data sets on your screen give the amount 3 groups of children receive for pocket money per week in pounds. We have dataset 1, which is all tens, dataset 2, which is an assortment of 8s, 9s, 10s, 11s and 12s, and dataset 3, which is an assortment of 0s, 5s, 10s, 15s and 20s. Let's take a look at dataset 1. The mean of dataset 1 is all the values added up together, which happens to be all tens, divided by the number of values we have, which also happens to be 10. So the mean is equal to 10. And now for dataset 2. Again, to find the mean of dataset 2, we add up all the values as shown and then divide by the number of values, which is 10. The mean of dataset 2 is also 10. And now for dataset 3. Again, add up all the values in dataset 3 and divide by the number of values. And we have 10 again. Notice that the mean of each data set is equal to 10. However, the 3 data sets are considerably different. So all the 3 data sets are different but have the same mean. We need to determine a way of finding the spread of the data. So far we have that the data sets are different but summarized by the same number. That, of course, is an issue. So the mean is not enough to summarize a data set, as very different data sets can be summarized by exactly the same mean, or even a mean that is similar. We need an idea of how spread out the data set is. For a data set, find the distance between each data value and the mean. So let's do this. Let's again take a look at an example. Here are the x values for dataset 3. Remember, of course, the mean was 10 for this data set as well. What is x minus the mean for each of these data values? So for the first data value, we have 0 minus 10. And also for the second. For the third data value, we have 5 minus 10 to give minus 5. Similarly, minus 5 again. And then 10 minus the mean, which is 10 minus 10, 0. And similarly here again. And then 15 minus 10 to give 5. And again 15 minus 10 here. And then 20 minus the mean, which is 10. And finally 20 minus the mean again, which is 10. Now let's take a look at what happens if we take the average of these values. So the average of the x minus mean values is We add up all these values and then divide by the number of values we have to give 0. And of course, this is problematic again, because clearly the values do deviate from the mean, but the 0 seems to imply that they don't. Clearly, the negative and positive values are cancelling each other out. So what we actually need to do is find the average of the positive values instead. So let's do that. What are the average of the mod x minus mean values? So now we've made all the negatives positive, left the zeros as they are, and the positive values have been also left as they are. Add them all up and divide by the number 10, because we have 10 values, which gives us 6. So here's a summary of our results. Now, the problem with averaging just all the positive values is that it's not mathematical, because we're doing some things to some values, but not to every value. What do you think is another way of making everything positive? There's a clue on the screen, so you might be able to pick that up. Of course, what we do is we square. So if we have x minus the mean, we square it. So all the negative values become positive, the zeros will stay as they are, and all the positives will also remain positive. So if we square the first value, we have minus 10 all squared, which is 100, and 100 again, and minus 5 squared is 25, and again 25, 0 squared is 0, and again 0 squared is 0, 5 squared is 25, and another 5 squared is 25, 10 squared is 100, and finally 10 squared again is 100. So now let's take the average of the x minus mean all squared values. So we add all these values up and divide by 10, because there are 10 of them. And that gives us 50. Notice that the units are in pounds squared, because we've squared everything. Of course, we've left out the pound signs for convenience. But the units eventually for this particular calculation are, of course, pounds squared. So at the very end, we need to square root this 50, and that gives us £7.07. The value 50 is the variance, and the value £7.07 is the standard deviation. So now let's define a formula for the variance. Remember, we started with x minus x bar. This was the difference between each data value and the mean of the data. We then squared it to make everything positive. We then added all the values up. And of course, the sigma denotes sum of all, and then divided by n, which was the number of data items, and came up with this formula. So it was variance equals sum x minus x bar all squared divided by n. And of course the formula for the standard deviation, we just square root the variance. And remember, we square rooted to make the sign consistent with the mean. So here's the formula for the standard deviation. Now both variance and standard deviation give an idea of the spread of the data. So the variance, sigma squared, can be calculated using either the formula we've just looked at or a rearrangement of this formula, which is sum x squared divided by n minus sum x over n all squared. And of course in the first formula x bar is the mean, and in the second formula you'll hopefully notice that sum x over n is also the mean. You can also find the variance using a calculator. And here the variance is denoted as S subscript little x over n, where this S subscript little x is sum x minus x bar all squared, which is sum x squared minus sum x all squared over n. And of course, remember the notation, sigma equals standard deviation equals square root of the variance. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2 part A first. The heights on your screen are those of 9 randomly selected pupils in Seher's year group. Work out the mean height of the pupils to 3 decimal places. So let's solve this. The mean is given by sum x over n, which is equal to, in our example, all these values added together divided by the number of data values we have, which is 9. And this equals 182.333. And now let's solve part B. Given that sum x squared is equal to 299,445, calculate the variance. So let's solve this. We're going to substitute the values that we have into the formula for variance. And this is the formula for variance we're going to use because we have sum x squared. And of course, notice that x bar equals sum x over n, and we have the mean from part A. So let's plug in the values. Here's sum x squared plugged in. Here's n equals 9 plugged in. And of course, we have that the mean is equal to 182.333 from part A. So we plug that in to the formula as well. And calculating this gives us that we have that the variance is equal to 26.344. And finally for part C, we are required to calculate the standard deviation to 2 decimal places. As you can see, the formula for the standard deviation is square root of variance. So let's solve this. From part B, we have that the variance is equal to 26.344. Therefore, since standard deviation equals square root of variance, we have that standard deviation equals square root of 26.344, which is equal to 5.13 to 2 decimal places. Now for group data in a frequency table, we have a different formula that you can see on your screen. This time we have frequencies here as well. So we have the x values and the f values which correspond to those x values. So hopefully you'll be able to see the similarities between these formulas and the ones you saw earlier. So sigma squared equals sum f times x minus x bar all squared all over sum f, or we have that the variance is equal to sum f times x squared over sum f minus sum fx over sum f all squared. So here are two formulas. And hopefully you'll be able to notice that x bar equals sum f times x over sum f. And of course we have that f is the frequency which we mentioned earlier for each group, and sum f is the total frequency. Again, the standard deviation is equal to the square root of the variance. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. The number of snowy days per week in a city are recorded for a series of 50 weeks, and they're given in the table shown on your screen. Work out the variance. So the formula for the variance which we're going to use has been highlighted. Let's solve this. Sum fx squared is 41 times 0 squared plus 2 times 1 squared plus 3 times 2 squared plus 4 times 3 squared, which is equal to 50. Sum fx is equal to 41 times 0 plus 2 times 1 plus 3 times 2 plus 4 times 3, which is equal to 20. And sum f equals the sum of all the frequencies, which is equal to 50. Here's a summary of our results. Now let's substitute in the formula for variance, which is here. We're going to plug sum fx squared equals 50 here, sum fx equals 20 here, and sum f equals 50 here, to give us 1 minus 0.4 squared, which is equal to 0.84. And now for another example. Pause the video and have a go. Press play when you're ready to view the solutions. The example asks us to calculate an estimate of the standard deviation of the lifetime of a sample of 35 bulbs, which has been shown in the table on your screen. So let's solve this. We've laid out the table in a different format in order to facilitate calculations. Notice also that we have a column for the midpoint of each interval. The midpoint for the first interval is the endpoints added together divided by 2, which is 7.5. And the midpoint for the second interval, 10 plus 15 divided by 2. The third interval, 15 plus 20 divided by 2 to give 17.5. For the next interval, 20 plus 25 divided by 2 to give 22.5. And finally, for the last interval, 30 plus 35 divided by 2 to give us a midpoint of 32.5. Sum f is the sum of all the frequencies, and that's 35. We also have fx in our formula, so we multiply each frequency by the corresponding midpoint. So for the first interval, we have 3 times 7.5, which is 22.5. For the second interval, 12 times 12.5, which is 150. For the third interval, 14 times 17.5, which is 245. And for the fourth interval, we have fx is 90. And finally, for the last interval, we have fx is 65. And sum fx is equal to the sum of all these values, and that comes to 572.5. And now for fx squared, similarly, each f multiplied by the corresponding midpoint squared. So here's fx squared for the first interval, and for the second interval, the third interval, the fourth interval, and for the final interval. And sum fx squared is all of these added together to give 10,468.75. So here's a summary of the results. We can now substitute each of these into the formula as shown to give 31.551. So we have that the variance is equal to 31.551. And of course, since standard deviation equals square root of variance, we have that the standard deviation is equal to 5.61 hours. This brings us to the end of this session. If you have understood its contents, you should be able to calculate variance and standard deviation. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.